Okay, quick reminder about quadratics, how to solve quadratics. Remember that you can use either method. If any of these methods, I should say. If we're looking at one in this form, it's probably the most common that you guys are going to choose to do the full formula. So remember that to do the full formula, this needs to be equal to 0. So right here, this one's not ready to do the full formula yet. You would have to add 23 to both sides first if that's the method you're going to use. But so let's go do, because this one is ready, A, B, and C. We're plugging into x equals negative b plus or minus square root b squared minus 4ac all over 2a. Okay, negative 1 plus or minus square root negative 1 squared minus 4 times a times c all over 2a. Negative 1 in the front becomes a 1. On the bottom becomes a 4. And now we're just simplifying this square root, the discriminant. So 1 squared is 1. And here I have a negative times a negative, so this is going to be positive 8 times 36. And I can't do that one in my head. I need to go grab a calculator. 8 times 36. It gives me 288. And then 288 plus 1 is 289. And 289 can actually simplify. The square root of 289 is 17. So always double check that, before you keep going and thinking that it's something weird. So 289, if I try to square root it on my calculator, oh, look, it's 17. So we get 1 plus or minus 17 over 4. And there's two answers here. There's the 1 plus 17 over 4 answer and the 1 minus 17 over 4 answer. So I get 18 fourths, which reduces down to 9 halves, and I get negative 16 fourths, which reduces down to negative 4. So my two solutions are 9 halves and negative 4. And what does that mean again? Remember that the solutions are where the graph touches on the x-axis. So this is touching at negative 4 and 9 halves. So what work did I have to do here? I had to write the formula. I had to write the ABC. I had to plug into the formula. I had to simplify. And then I noticed that the square root could be taken. So I go all the way and get those whole number and fraction answers. What about if the one on the test is not a perfect square root? Then you're going to keep it in simplified form. So you've had experience with, what do I do if this isn't a square root? What do I do if there's a negative under there and you have to pull out an I? So remember, all that stuff still applies. This one happened to have a perfect square root. Now let's go look at this one. You could add 23 to both sides to make it equal to 0 and do it the same way, but this is nicely set up to complete the square. Step 1, make space. Step 2, go off to the side and do the B work. So negative 12 divided by 2 is negative 6. Negative 6 squared is 36. This B work tells me what I'm going to be adding to both sides. Now, why did I just complete that square? So that I could get these perfect square factors. What factors make this trinomial the x minus 6 squared factors? Because 6 times 6 is 36, and 6 plus 6 makes that negative 12. Notice the negative has to be in the middle because the middle there. Over here, what is 36 minus 23? It is 13. So now I can take the square root of both sides. I'm going to get x minus 6 equals plus or minus root 13. Root 13, there's nothing I can do with that. Hey, so I just leave it there. So my final answer is 6 plus or minus root 13. That is still 2 real roots because it has a positive discriminant. So this is 2 real roots, meaning 2 places that we touch the x-axis at this spot. 6 plus root 13, 6 minus root 13 are my 2 real roots. Over here, we also got 2 real roots, or 2 places where we touch the x-axis. What about this guy? There's a couple ways you could solve this. First way might be that you see the factors, x minus 11, x plus 11, because it's the difference of two squares. So we set each equal to 0 to solve. So x equals 11 and x equals negative 11. Those are my two real roots. Now, what if you didn't see the factors? Then maybe you just solve by square roots, the other method. So I'm going to add 121 to both sides. And then I square root both sides, and I get x equals plus or minus 11. Again, there's my two real roots. All right, let's summarize these methods. Here's doing the full formula. Here's doing complete the square. Here's solving by factoring using difference of perfect squares. Here's solving by square roots. Those are our four methods that you have to choose from. If you do these methods, this is all the work that's required on them. So make sure you're showing your ABC, you're showing the formula, you're showing the plugin, the equals goes all the way down, you show your two real roots. On this one, make sure you show the B work, make sure you show what you're adding, getting those factors and showing that final step for those two real roots. If you're showing factors, the factors are set equal to 0 by 0 product property. They can each be set equal to 0. If you're showing solve by square roots, you got to show the adding square root, etc. Adding 121 to both sides. Anyways, got to show full work, whichever method you decide to choose. Remember that these don't always work out to a perfect square. You might need to know what to do with a negative discriminant, taking out that I. You might need to remember what to do on simplifying radicals. So be prepared for this answer at the bottom being different. How'd you do? Do you feel ready?